Okay, the dreaded cylinder. This is a hydrometer problem. How many different types of problems are there, right? Basically, this buoyancy problem, right? One of the types of problems is if you've got a liquid, right, and you've got something that's less dense than the liquid, it will float. In this case, it's a little cylinder that's going to float vertically like this, and then you can deduce from how deep it sinks. It'll sink deeper into less dense fluids, right? But how deep it sinks tells you the density, and usually they have a scale on them. This one apparently doesn't, right? Okay. Now here's the notion: is that at the water line, right? This thing is there's some submerged volume. Okay. We know that submerged volume, right? The displaced fluid, right? And the fluid here is 865 kilograms per cubic meter, right? That displaced fluid has a mass of 37.5 grams because I believe it's Archimedes' principle or something like that. The basic principle here, right, is that objects that float displace a amount of water or fluid, right, in this case, equal to their own weight or mass, okay? So we know the mass of this stuff that's displaced, and in fact, the volume of that cylinder that's below the water, that volume, okay, has a mass of 37.5 grams. So the first thing I'm going to do is I know the mass of the fluid displaced. I know the density of the fluid, and I'm going to find the volume of the fluid displaced. So volume is mass divided by density. This is the definition of density, right? So 0.0375 divided by 865, and that's kilograms per cubic meter, right? So 0.0375 divided by 865. I'm going to store that in V for volume. And that is 4.33526 times 10 to the minus fifth, approximately, cubic meters. Not very much, right? Okay. The next thing I'm going to do is this is just a cylinder, right? And so I know that the volume of that is also pi r squared h. This is something you need to memorize. Okay. So that part of the cylinder, oh yeah, we want to figure out how far it'll sink, so that's what we're trying to figure out. Okay, so h is what we're trying to find. So that equals pi, and then that is the radius, right? So and just be very careful of radius and diameter. Okay, so that is 0.00920 squared. Yes, I do believe that's correct. Okay, times h, and then of course that equals the volume we figured out, right? Now I can figure out this, right? So I'm going to divide what's on my calculator by parentheses pi times 0.0092 squared. 0.163, so the h is ta-da, 16.3 centimeters. That's all well and fine. You can just stop right here. I want to show you the solution that Michael came up with. I thought this was especially kind of cool. Okay, basically he figured out that the forces to the side here, the pressure on the side, all cancels out. It's the pressure on the bottom that matters, right? So what he said was that pressure times that area equals the weight of the whole thing, right? Okay, so he said rho GH times pi r squared equals m times g. Right, let's just try it out here. It should work, right? Okay, so 865 times 9.81 times h, which we don't know, right, times pi times 0.0092 equals 0.0375 times 9.81. Of course, 9.81 goes away, and we end up with, yeah, it's going to be exactly the same thing. Oh, we got to square this guy. There we go. Okay, so let's go. Yeah, it's exactly the same. This divided by this, and then that in turn divided by this. That's great.